Alrighty, students, we're looking at this concept of acceleration, which in its equation is fairly simple, but in application can sometimes feel a tad bit confusing. So let's look at an example here. We've got a speedometer, and I'm going to use this pencil as the needle of the speedometer so that we can look at how speed changes through time. Now, the equation up here says change in velocity. So for my first example, we're going to keep it a tad simpler, and we're going to just talk change of speed for a moment here. So let's imagine that you're in a car and the speedometer, when you stomp on the gas, does something like this. Right? Now, obviously the speed is changing, but in order to calculate acceleration, we would need time. So let's do a little hypothetical time here. Let's say it went like this. 1 1000, 2 1000, 3 1000, 4 1000, 5 1000, 6 1000, etc. Right? So if we wanted to do a calculation for this here, we could come to the top and say the change in velocity was 60 miles per hour. Change in speed, it went from 0 all the way up to 60, and it did that in 6 seconds. If you do the division here, 60 divided by 6 is 10, but then let's look at the units. What were the units? Well, none of these cancel, so we still have miles per hour. Now that's divided by seconds, so this is 10 miles per hour per second. I like to write it like this because it really highlights this idea that every 1 second the speed changed by 10 miles per hour. And hopefully you saw that, right? I did it on purpose so that as we hit the gas, it was 1 1000, 2 1000, 3 1000, 4 1000, etc. So you can see the speedometer was increasing by 10 miles per hour for every second of acceleration. All right, now to add in this idea that acceleration is actually a change in velocity, I've altered our little speedometer here. We're going to call this the velocirometer now instead of a speedometer. Notice that there's a 0 value, but I moved it up here so that now we have both positive velocities and negative velocities, right? Positive velocities would mean moving one direction versus negative being the other way. We typically think of right as positive and left as negative on a number line, right? So if we have our car again, our car is at rest, we could stomp on the gas, and if the velocirometer changed like this, that would tell us that it was accelerating in the positive direction, right? It's becoming more positive in velocity. Or we could stomp on the gas and maybe it goes like this, telling us that the car's going faster in a different direction, right? Now, let's think about actually solving something here. Now in black, that's what we did on the speedometer side, so we'll use a different color here this time. Now imagine a car that is, let's maybe make it a little more interesting. It's already driving along at 10 meters per second in the positive direction. The driver stomps on the gas and it does something like this. 1 1000, 2 1000, 3 1000, 4 1000, 5 1000, 6 1000. Okay, so this time the car went from 10 meters per second up to 40 meters per second. That would be a change of 30 meters per second, and it took 6 seconds to do that. When we do our division, 30 divided by 6, easy 5. The units here, it might seem like seconds would maybe cancel those seconds, but those seconds are already under meters. So this is like saying divide by seconds again. This is 5 meters per second per second. So we kind of see some unit similarity there. And like I said before, I kind of like to write it like this to really emphasize that every 1 second, there's a change of 5 meters per second. And hopefully you saw that. I did it on purpose. It started at 10 and we had a 1 1000, 2 1000, 3 1000, etc. Every second that goes by, the velocity increased by 5. Now, acceleration doesn't have to be positive. The word we tend to think of as speeding up, but in physics, acceleration just means change in velocity, and that change could be negative. So a car could be moving along here at 10 meters per second, like we had, but maybe it hits the brakes and the speedometer or velocirometer does this: 1 1000, 2 1000. and stops. In that case, it would have changed its velocity from 10 down to 0. That is a loss of 10 meters per second. And it took 2 seconds. So we would have a 10 divided by 2, which is 5, but this time it's negative 5 meters per second, right? For each second of slowing down in this case, the car lost 5 meters per second on its velocirometer, 1/1000, 2/1000. Now, final thought. You can be in the negative numbers and you could have a positive acceleration, which brings your velocirometer towards the positives. You could be in the negatives and accelerate to be more negative. You can be in the positives and accelerate to be more positive, or in the positives and accelerate to be more negative. It's all about how much the velocity changes per unit of time, and thinking about the positive and the negative as the direction of change. How is the velocity changing?